Hello friends, my name is Robert. I work at eazyBI support and frankly, I stand between you and lunch. And you may naturally wonder what we are about to descend into. This will be a quick dive into a particular form of complex calculated measures. And I will give you some bits and pieces that you hopefully will, in time, glue together for that will result in a beautiful calculation with or without the Descendants function. So, what are they? The Descendants. Why are they so good or so bad that they deserve their own presentation? Well, usually we don't use it on its own. You see, it's actually an ensemble of nested functions, getting issue, dimension, issue level members, filtering them, and then counting the ones that match the conditions, or calculating a sum or averages. So don't get me wrong, I'm not about to throw the Descendants under the bus. There is a wide plethora of options to get a set of members to filter through. And we have found that Descendants work the best. This talk is more about the tools we have and know, how to recognize when iterating through issues is necessary and when it's just an old habit, with better options available. Because the thing is, whenever we get a ticket regarding poor performance, it's usually this lot. But just like in the movies, they are not at fault for everything. With the introduction out of the way, these are the three main topics of this talk. How eazyBI, you could say, saves and retrieves data from data cubes, some guidelines, and some examples when I found myself more than knee-deep in complexity. So, eazyBI imports data, in this example, Jira data, into a separate database and reorganizes the data more suitable for data analysis into a multidimensional data cube. And it's easier to comprehend as a star schema, but don't confuse it with the pyramid schema. You see the difference is between the two is that in the pyramid schema, someone else gets all the money and you get all the issues. So back on track. In the star schema, on the outside, you can see the dimensions, and the measures are in the middle. Measures are actual numeric values that are aggregated on the database level for dimension members. Just like in the picture, in reports and calculations, numeric measures are the ones that tie all the different perspectives, the dimensions, together. Whenever you create a report, drag a dimension in report rows, columns, or pages, select a measure, or create a calculation, eazyBI makes a query to the database, to the data cube. But all queries are not created equally. Some are faster, some are slower. For example, the 3 standard measure types per data source. They issue absolute measures like issues created, issues resolved. Those are blazingly fast. And these also include numeric and date custom field measures. Workload measures like hours spent are a tad bit slower. Not to find excuses, but a single issue can have a lot of work logged, as we found out yesterday. And then there are transition measures dealing with this issue change history. Still fast, but you get it why I mentioned them last. So what would be the fastest way in seeing results in your reports? Yes, these predefined measures. But sometimes you just can't live on vanilla data. Just like with ice cream, humans thrive when complicating matters. And that is where creating custom calculations come in. The next best thing besides predefined measures are tuples. Stefan already introduced them yesterday, but basically a tuple is made of one member and only one member from each dimension. So in other words, it's a combination of members from one or more dimensions, but only one member from each of those dimensions. How do other dimensions, for example, not referenced in the tuple, affect it? Well, they don't. If they are not in the report, that is. For a better comprehension, I rewrote the tuple. So the current hierarchy member is used for all dimensions not referenced in the tuple. Suppose the assignee dimension user level is in the report. The tuple will return the number of issues in progress for each assignee. Project time, etc. are not in the report. They don't affect the tuple result. So in the Jira issues cube, upon data import, eazyBI has categorized Jira issues, issue characteristics, status, project, priority, assignee, so on, and ties them to the respective numeric values, the measures. That's allowing the results, allows result retrieval for fundamental reports and tuples. But let us picture a different data cube and data retrieval to emphasize the difference. With 2 dimensions and some metrics, and for each attendee, we have some uncategorized information. Let us call them properties. I know, humans don't like to be categorized or labeled, but just bear with me. Let us have a closer look at one of the community days attendees. Right out of the page, I think he's fond of food. So suppose the caterers want to surprise everyone with their favorite dish at lunch. And, well, yes, they tasked me with this, an obvious choice. Well, I don't have the data categorized. I can't really retrieve the information. But each one of you probably know your favorite meal. So to find out this particular detail, I could interview each one of you. No, I should have done that earlier when you were coming back from the coffee break. Imagine the ordeal. A queue ensues at the entrance. You are outraged. What's the holdup? The caterers are annoyed. Why is it taking so long? Rodrigo is waiting to present and is wondering, where are the people at? And I, the one that's interrogating, interviewing, I would probably time out. If I knew beforehand that I need the data, I could have prepared, interviewed you, for example, yesterday, or sent you an email at an earlier stage, and categorized the data. How would that look? Well, imagine, again, this whole room is the favorite dish dimension. Each table is a member of that dimension, representing a meal. So the people sitting at the table is the number of attendees having that as their favorite. I no longer have to interrogate each one of you. Attendees are categorized by their favorite dish, and I can easily find the right number and without a holdup. Each table is like a tuple, a combination of a dimension member and the number of attendees as a measure. So by categorizing data, we go from this data cube to this. And we know data can be saved and retrieved, how tuples retrieve data, but tuples can't cover all requirements. I think we can welcome the Descendants back on stage again. So they are, for some, relatively easy and fast to write, and the concept gets particularly obvious as you can carve out the desired issues inside the filter conditions with issue properties and measures. It's quite similar to writing a JQL and viewing the list of issues in Jira. Granted, it's slower to execute, and the larger the data cube, the slower it gets. But when you can't do without them is when there are several conditions on the same multi-value field. For example, the attendee has hobbies, so it's not empty, and those hobbies are not related to video games. or some alternating conditions from different fields. You are from a particular company, or your favorite book author is Stephen King. And for example, in small data cubes, you won't even feel the difference when you use, you could say, a predefined measure or a descendant measure. So when not to descend? Well, the obvious choice when you can use predefined measures, it sounds dumb, nah? No, but it isn't. It is easy to overlook the best solutions when you have learned something trusty and reliable as descendants, and even more when you have created it, you know what it returns. For this, I recommend consulting the eazyBI documentation page about the available measures, because every now and then we add some new ones. And speed. I'm talking Keanu Reeves and Sandra Bullock speed, so whenever there are situations when the boss will explode, if the report takes more than 10 seconds to load, then I advise against complex calculations. And of course, large data cubes. Those should rely on predefined measures, or categorize the desired information upon data import, for example, with JavaScript calculated custom fields. So how to do it properly when you must? Whenever possible, set the first filter condition by a dimension property. In this case, the issue resolution date. And try to avoid multiple conditions within the filter condition, because unfortunately we don't know which one would be executed first for the set of issues. Instead, you can add additional filters in the numeric expression with the case when statement to further narrow down the scope of issues. That way, applying you could say the new condition on a smaller set of the filtered issues. Or in the count function that doesn't have the numeric expression, use this approach in the main filter function. And that leads us to the numeric measures. Use at least one numeric measure, and at least doesn't mean that more is better. It means use one and more if you must. And also remember the 3 standard measure types and their characteristics. And be aware of your surroundings. The amount of imported data in the cube, the dimensions you have selected in your report, the selections in those dimensions will affect the results and the duration of the calculations. So we have done a lot of imagining, so we could have a look at some real-world examples I have encountered. There were no performance problems in this case, but the requirement was to retrieve the number of parent-type issues, ignoring subtasks. The user had the issue type dimension in the report rows, and the calculated measure seemed to return correct results for individual members only. For all issue type members, the result included subtasks. Interesting, it doesn't show coloring. It's red, by the way. The background for the calculation. And now we can focus a little bit. Nothing changes, sadly. So the descendants look solid, okay? But then the condition is for the issue type dimension property. As you can see on the line 4, it looks for the issue type dimension property subtask. Strange. To use the condition the correct way, that is to filter the dimension that is used in the descendants, we could rewrite it this way. We check the issue dimension property parent issue key. Only subtasks have value in this property, so it's safe to say this would retrieve only standard issue types and would work correctly without the issue type dimension in the report. Measure? Good. Issues created. Ties the calculation to the report context. But I think we can drop the charade. The user was so close with the issue type dimension. Let us go back to the original. In my presentation, there's a narrower scope on the issue type and the measure, so it results in a tuple. Sometimes the answer stares right back at you, and you are none of the wiser. The idea was to use the by type hierarchy of the issue type dimension to retrieve the standard issue types only. The next example is about retrieving the number of medium stories in various statuses. The user had this calculated measure, and it caused performance problems. It uses the sum function to retrieve the results. But the descendants don't seem quite right. As you can see on line 3, it doesn't have the usual issue current member and issue definition. It uses the issue members, so the descendant function accepts the dimension and dimension level to iterate through, but in this case it gets a set, but descendants is pretty chill, I guess, and accepts set as a member as well. Not very efficient though. So the sum function needs a number to sum it all up, but I see only strings in the conditions. There is no numeric measure to sum. Let us consult the eazyBI documentation page that says returns the sum of numeric expressions evaluated over a set. We lack the numeric expression, but we have the set. It is returned by the filter function. In such case, eazyBI will most likely fall back to the default measure. In the JIR issues cube, that's issues created. And there can be cases that other measures in the report are used instead. So I would advise always use one numeric measure so you know what is calculated and not leave it to chance. The conditions are based on the issue type and t-shirt size. And then there are particular statuses. And one issue can be in a single status at a time. So if we would narrow down the scope that it's not visible here, we would see that issue type, t-shirt size, and status kind of could form something similar to a tuple. Nope, not really, but almost. We can build a tuple from the combination of a measure, the issue type, and t-shirt size, and use it as the numeric expression for the sum. But instead of iterating through all issues, to find the ones in the desired statuses, the calculation considers the set of statuses instead of iterating through issues. And in my small data set, in the same conditions, the original formula took 11 to 12 seconds. This improved calculation took 50 milliseconds. The next case was very cryptic and obfuscated. The main concept was the main complaint was slightly off results, and of course performance problems. The report had day-level members of the time dimension in rows and an aggregated calculated member of custom field dimension in pages. There was nothing wrong with the Descendants ensemble, and it had a measure as the first condition in the filter function. It was a calculated measure, not a property. In line 4, the scoped all. And it had a nice touch from line 6 through 13 with the case when to apply another condition on a smaller set. But again, a calculated measure. Let's have a look at these two measures. Okay. Another calculation that iterates through issues. This is not efficient. As eazyBI iterates through issues again, for every issue it finds on the first Descendants. Usually you can combine the conditions and define a single calculated measure that takes into account all these conditions. Let us have a look at the other one. Ouch. At this point, I was angry. I was angry not at the user who reached out with the problem, no. They've done everything they could, shared enough information for the first optimization steps. I was angry at me because I couldn't understand what's happening in all of these calculations and how it all comes together. During the process, I think I went through all 4 stages of grief. They say it's 5, but I think I skipped the depression one. And the measure referenced in line 26, guess what? It was a descendant again. And it was also in the previous one at the bottom, so yay. And we started here from a blank page. Understanding the requirement, testing and comparing results. And yeah, it turned out the user wanted to see the number of issues that had a value change in a custom field for each day. That's why they had day-level members in rows. The custom field dimension was in the report pages with an aggregated calculated member holding the values that are considered the scope. Any change from these values to any other was considered descoped. The calculation had to exclude issues that had a change out the scope and back in on the same day. And issues that were created with the scope values, but were changed out to a different one on the same creation day. So a wide variety of requirements. After some back and forth, we came up with a calculated measure, a single calculated measure, but not this one. Embarrassingly, when preparing for this talk, I noticed inconsistencies. So yeah, I came up with an even shorter version. Good old Descendants, still, because if we consider changes from and though for a single issue, we must look at every single issue. And I use the transition from condition to retrieve issues that have transitioned out of the desired scope. So we get all the issues that have transitioned out. But then, in the case when, we exclude, make another condition that looks for issues that don't have a transition into the scope at that day. And this excludes the issues that are created with the value and then moved out, or bouncing back and forth on the same day. And the transition measures are already numerical, so I just use the number 1 as the numeric expression. And with my data, the original took around 13 seconds to load. The new calculation took a little bit under 5 seconds. But I'm still afraid that this is not the final form of it. So, the takeaways. The major one is, don't descend if you don't need to. But if you need to, filter by property first, use a numeric measure, and try to use compact cubes in the accounts where you need to descend, or categorize the data with custom JavaScript code. Thank you.
Days today go. Questions?
No.
Yes. I'm afraid of those buttons.
Hello. So I wanted to know the difference between that function current member and current hierarchy member, and when to use one or another.
You use the current member when you know which hierarchy you want. So in the issue, current member, issue, when we iterate through, we already know we use the default hierarchy. The best use for current hierarchy member is when, for example, you make calculations on time dimension. because you never know which hierarchy, the default one, the weekly or fiscal one will be used. So you can reference the actual member that is with the current hierarchy member. It will like work for all hierarchies. I hope
Okay,
it answers.
thanks.
Yeah.